Okay, warriors, this is the beginning of the semester, so one of the things we want to make sure you're happy with is how to answer questions in our space and that you know what's going on. So the first thing is going to be about communication and how to communicate like a scientist. So we're going to use the basic format of claim, evidence, reasoning. And the first thing, your claim is always what you think the answer is. Your evidence is either going to be data or model based. So you'll either be collecting data that you'll use for your evidence, or you'll have a model that you've been playing with that will be your evidence, but it will be either data or model based. Your reasoning then is why the evidence fits the claim. So if we were to try to answer the question, which are better, pancakes or waffles? I might make a claim that waffles are better. Ooh, notice how I almost switched camps. Waffles are better. My evidence will be because they have pockets. And my reasoning might be because the syrup gets caught in the pockets. So every part gets syrup. That could be my claim, evidence, reasoning statement. So you can see right away I made a clear claim. I have evidence that relates back to my claim. In this case, of course, it's not data-based. It's going to be more of a model-based, right? I can know what a pancake or a waffle looks like. And then my evidence statement relates both my evidence so it relates my evidence back to my particular claim. So one more quick example, would there be, so if I were to redo that, and maybe I want to make a different kind of claim, we'll put that in a different color, we'll put that in a different color so we could see someone else may still make the claim that pancakes are better, and their evidence might be cooking is faster, and my reasoning might be because I can cook multiple pancakes, on a griddle. I promise that's supposed to be an RI. And you can only cook one waffle at a time. So no matter what, I can get a claim, evidence, reasoning statement out of that. I would encourage you to practice with something like, what's the best, if you could live anywhere in the world, where would it be and why? Because then you can make a claim, you can make some evidence, you can make some reasoning. The hardest part, I think, at first is making that distinction between your evidence and reasoning statements at first. So don't get too frustrated or hung up on that part right now. You'll get better at it as we go because we'll use that always in our science communication. The other thing we talked about was how to do good science. In this class, you will be most of the time designing your own experiments. And so we need to know about 3 different words here. So the first word we're going to talk about is bias. So we always have to make sure, you've probably heard talk about bias in society. Most recently, there's been a lot of talk about how people or society itself systems can be biased. And sometimes I think that's an easier way to think about it, right? Bias is anything that makes it unfair for anyone. And so when we think about it in science, it's anything that will make an experiment results be unfair, that would favor one set of results over another. So if we think about heating something, we would want to heat two different trials or two different pieces of equipment the same so that one doesn't appear to heat faster than another. Or in this first lab, when you do your gravity lab, you want to make sure that you're not tilted, that something might roll, or you might try changing directions or places on the hoop so that it is not biased in terms of an unfair result. So we know that in a sports race, like if one person takes steroids and another person doesn't, it would be biased probably towards the person who takes steroids. If you gave someone a head start and you didn't give someone else that same head start, the race would be biased toward the person with the head start. So it's anything that makes it unfair. Next, then we talked about how do you make sure that you don't have bias in an experiment. Well, there's two pieces that go with that. We're going to make sure we have reliability and validity in our experiments. So reliability means that it's not a fluke result, right? We've done multiple trials of that particular experiment, and we might, this says the same scientists or different scientists. I kind of have a typo there. Or it could be the same experiment, or it could even be slightly different. And then let's fix this while we're at it. And so if you think about it, if I only do something once, it could just be a fluke, right? If I do it twice, well, that could just be coincidence. But if I do it 3 or more times, that's probably a real result. So when you do experimentations, we will ask you to look for reliability. Now, this could be you and another team. So that would be where the different scientist comes in. If you have a different team run the same experiment, it could be you repeating it over and over again. So on these gravity labs, we will expect you to run multiple trials because each trial only takes a few seconds. But on other experiments, we may need to have someone else try the same thing because we won't have enough time to repeat it ourselves. So that's what reliability means, is someone tries the exact same experiment or nearly the exact same experiment to see if we get the same result. Now, validity is similar, but also a little bit different. On this one, we test the same thing, but in a different way to make sure that we can draw the same conclusion. So, for example, if someone makes the claim that my dad is bigger than your dad, let's make that a different color. So, my dad is bigger than your dad, right? And so let's say we went to go get some evidence for that very audacious claim. And so we might measure by height, and we might test by height, right? And so my dad comes out as 6 foot 3 inches tall, and your dad comes out at 6 foot 0 inches tall. My claim would then be supported by that evidence. But if we then tried it by weight, and then my dad came out to be 200 pounds, and your dad came out to be 210 pounds, we cannot draw the same conclusion, right? Now, so on this one, my dad is bigger, but on this one, your dad is bigger. And so that is not valid. We've tested that claim in 2 different ways, right? So one tested by height and one tested by weight to make sure that the same conclusion can be drawn. And here we can't. So this would not be a valid claim. It would not be a valid result. And we would have to find some other measure to see whose dad is bigger, or to just throw out that claim altogether. Now, these words here, reliability, bias, validity. These are not anything you're going to see on an exam, but they are words we will expect you to know. So we will be using these whenever we are running experiments. How did you ensure you don't have bias? How do you know that your results are reliable? How do you know that they're valid? Because this is how good science works, and this is how we know we can trust science, because there's lots of people making sure that there isn't bias, that we have reliability, and we have validity. All right, hope your semester's off to a great start.